I don't know about you, but when I spin up a setup like this, I want to know that those are the right type of clamps. Hello Internet, my name is Quinn and this is Blondie Hacks. Faceplate setups are always mildly terrifying, but they can be a little less so if you use the right types of clamps, and potentially you don't then end up in the emergency room awkwardly explaining to the doctor how you ended up with one of these in your face. So let's make some faceplate clamps. Can you use regular strap clamps on the faceplate? The answer is maybe. Some strap clamps have this type of tooth on them where it's kind of a sawtooth and there's a little bit of an upward angle there which helps prevent the pieces from pulling apart. Other sets though, like this little one here, the little steps are 90 degrees and there's nothing keeping those steps from pulling apart. And so under the centripetal forces of the faceplate, the wrong type of strap clamp might pull apart and send the little blocks flying off into space. Even the sawtooth kind, I'm not sure I would trust very much. What I'm going to make are a style of clamp that are like strap clamps, except that everything is captive. There's nothing loose that can fly apart. I'm going to model them after these little strap clamps that I have because they're a really good size for the types of things that I do, and well, I happen to have this piece of stock here that might be a good fit for this project. I don't know what kind of steel it is. Past me apparently thought it was maybe 4140. Whatever it is, it'll be fine. And I think it's just long enough to get 4 of these clamps out of there. The exact length of these is not critical, but I'm going to use up this whole piece to get 4. So I'll show you an easy way to get 4 accurate pieces out of any piece of stock that you might have. I start by setting my dividers to 1/4 of the length of the stock and spacing out 3 rough cuts that I'm going to make here. And this will get me in the ballpark, and then we will refine these dimensions so that all 4 pieces end up exactly the same a little bit later here. While I'm roughing this out on the bandsaw, let's watch and see if I can manage to keep that jar of cutting fluid from vibrating off the table. Will she keep it on there? Will she? Success. Next step is to create a reference face on each of these 4 parts. They're all rough cut and they're all of varying lengths, probably plus or minus a 1/16 of an inch, something like that. But that's not good enough for us, so I'm going to start by tapping the first piece in the vise here, and I'll side mill one face there just until it cleans up so that it's a clean machined reference surface. And I can tell already that this is definitely 4140. Having worked with it a fair bit lately, I'm kind of used to how it machines, and that's definitely what this is. So that's good. It's good material for clamps. With that first piece done, I swap in the second piece. The position of anything doesn't matter here. How much we're milling off doesn't matter. We're just cleaning up one end of each part and leaving the other end rough cut. Next, I want to find which piece is the shortest because that's going to set the final dimension of all 4 parts. Now, if the parts needed to be a specific dimension, then you would still need to do this, but you'd have to make sure that the shortest piece ended up larger than your final dimension needs to be. In a case like this, where I don't care what the exact length is, I just want all 4 of them to be the same, then it's easy, just pick the shortest one. And now I put that in with the remaining rough cut end facing outwards. Tap that in. And now I'm going to set up an end stop on the vise. And this is key because we're going to be doing a little bit of mass production here. That's going to reference all 4 pieces to the reference surface that we created on the other end of them. Next, I touch off and machine this guy down, again, just enough to clean it up. In this case, because it doesn't matter what the exact length is, I just want the parts cleaned up on both ends. I'm just machining this one until it's cleaned up. And that becomes the length that all 4 parts will be machined down to. Now in my case, I measured it just to see where I was at, and it was really close to a nice round number of 2 1/4, so I just milled it down a little further because it's nice when things are round numbered sizes. You never know when that might come in handy. Now comes the cool part of the trick. I zero the DRO on the x-axis right there, and now I don't have to measure anything else. If you don't have a DRO, you could also just set an indicator on the end of your table for this. But now I can set up the next piece, again with the reference face on the end stop there, the rough cut face facing outward, and machine that down to 0. Now you can't necessarily do it in one cut. As you can see here, this would be too deep a cut for my little mill. This second piece happens to be quite a bit longer, but I can move the cutter out, touch off, and then go look at my DRO, and you see it says I'm at 57 thou. That's how far out the end of this part is from where the other one ended up machining down to. So I can dial in a reasonable cut here, say 25, and just machine down in whatever comfortable passes your machine can do until you get to 0 on that x-axis. Then without measuring a single thing, these two pieces are going to be exactly the same length when we're done. It's a very simple way to do a lot of parts the same length, regardless of whether they need to be a specific length or just the same length. Here's those first two parts here stood up on the reference surface there, and you can see that they are really dead nuts the same length. You can see a line between them because the edges are both chamfered on the top there, but those are within a couple tenths of the same length. Very simple. So I did all 4 parts that way, and now I can set up one of the parts again with the end stop on there, and I'm going to use the edge finder to find the center line. So if you're not familiar with this, you find one edge, and then you 0 the y-axis, you move across to the other side, and you find that edge, and that gives you the width of the part plus the diameter of the edge finder. Then you hit the half function on the DRO, which gives you half that distance, then you move the y to 0, and now you're right on that center line. What's great about using the half function that way is that it automatically compensates for the diameter of the edge finder and any other similar variables that you would have to account for. Then I find the end of the part. In this case, I do need to account for the radius of the edge finder, so I move in by that amount, 0 my x, and then I can translate over to where I want a hole. This hole is going to be threaded on each part. Of course, I want all 4 to be identical, so I'm going to swap in the second part after center drilling and center drill again. Once again, this is just basic mass production on manual machine tools with the use of an end stop. You do each operation on each part and then change tools and do the next operation. The tool changing is usually where you spend most of your time, especially on a mill like this where you have to crank the column up and down a lot to change tools, so it saves you a lot of time if you can swap parts more than you swap tools. Now I'm going to put the big slot down the middle of each clamp, and because this is 4140 and an inch thick, I need to make this easier on my little machine tools. So I'm going to start by chain drilling. I make a bunch of center drills a certain distance apart using the DRO, and then I proceed to drill out each of those center drills with a drill that's a little smaller than I want the final slot to be. Now the trick with this technique is you want to get those center drills close enough together that the holes overlap as much as you can get away with without the drills wandering off into the adjacent hole. And you can overlap them quite a bit, but I got a little greedy here. As you can see, that drill is deflecting into the other hole. So this was too close together, so I had to concede defeat there and just drill out every second center drill. And then I came back in with a smaller drill and drilled out the ones in between. Once again, for all these operations, I'm doing all 4 parts for each tool change. Next I come in with a 2-flute end mill. You could do this with a 4-flute as well because we've pre-drilled, but I plunge down each end of the slot and at several points along the slot where the overlaps are on those drills. I want to basically eliminate most of the material here. Even with that chain drilling, there's still too much material here for my little mill in an inch of 4140 to side mill that all the way out. You can plunge much more material with an end mill than you can side milling it. So plunging in a few places along the way first gets rid of the bulk of the material and prevents chatter. And then finally we can run the end mill down the length of the slot to clean up the sides. You wouldn't have to jump through all these hoops if you have a bigger mill. Something like a Bridgeport, I'm sure, can just cut this slot in one pass all the way through the material with a single end mill. But this is how you can work in tough materials like this on small machine tools. Or if you're on a big machine and you're cutting something really big and really tough, these same techniques would be useful. Next I'm going to counterbore this slot. Counter slot? Anyway, I'm going to make a relief cut, let's say, down the length of this slot partway down for the bolt heads. This way the bolts are recessed inside the clamp. This is a design aspect of the clamps that I'm copying that I really, really like. On small tools with small parts, that recessed bolt head has very frequently made the difference between a setup working or not. So I want to copy that feature here. In this case, there wasn't a lot of material to remove and the cut wasn't very deep, so I could do it in a single pass, even on my machine, although this was right at the limit of my machine. Next, I'm going to chamfer the top of this slot because it'll look nice. This is a technique I learned from Bernie over at Works by Solo. You should check out his channel. I'll link to it below. He's awesome. It's really very simple. You take any old chamfering tool. I'm using my Zero Flute chamfering tool here. You plunge it down at one end of the slot, gauge the power feed, run it down to the other end, stopping at the other end, and you're done. Just like that, you get a perfect chamfer all the way around the top of the slot. It looks like a complicated feature to make, which is what's so great about it. Next, I'm going to copy the nose off this other commercial strap clamp and do a 3-angle treatment like you see here. And this is not just aesthetic, this really increases the functionality of the clamps a lot. It really helps get them into tighter spaces and at weird angles on parts. So I'm going to start with the big top angle. I've got my adjustable angle table here, and I've got a backstop set up, and I'm going to just clamp all 4 parts in place like so. The nice thing about clamps is that they're, well, designed to be clamped, so it's really easy to clamp them to things. Anyway, I'm going to do all 4 at once here. This is a very quick and easy way to do this. I just measured the angle off of that commercial clamp, and I'm going to mill it down to a depth that, I don't know, looks about right. No measurements here. Just want to make sure not to get into the slot there where the bolts are. I'm really becoming a fan of 4140, I gotta say. It machines beautifully, it leaves excellent finishes. It's tough stuff, especially on these small machine tools, but the results have been consistently really nice with it. Now I'll clear off the table and set up the next clamp vertically here, using a little square there to get it square on the fence, and then I'll clamp it down and I'll machine one of the side angles here. Once again, I just measured the angle on the commercial clamp and set my table to that. So I think I went with 25 degrees here. In this case, the depth is determined by the previous angle, so I'm milling down until the top edge of the 2 angled faces meet up nicely here. Just basically going a little bit at a time and doing that by eye. However, in this case, once I got to the right depth, I decided that I just really wasn't happy with that angle. It was going to leave the nose of the clamp being too big, too kind of chunky looking, and I wanted something a little svelter than that. These are small clamps, so I want a small nose on them. So I cranked the angle over to 45 degrees and then machined that down to the same depth to correct the angle there, and that I'm much, much happier with. I did all 4 parts that way, and of course the setup is repeatable here, so I don't have to measure the other 3. I'm just milling down to the same value on the quill DRO each time. Then I flip the parts over and machine the same angle on the other side. Once again, that's going to repeat, so I don't have to measure anything for the second side of each part. To finish these off, I decided I wanted to do a fillet on the back corners. I could chamfer them, but I thought a fillet would look nicer. So I busted out my corner rounding fixture that I made in a recent video, and I centered this up on the rotary table. I wasn't sure if this was going to work. I do have a hole in the end of each part, but the hole is not the center of the radius that I would want to cut, and that is a requirement for this fixture. But I thought I would give it a try anyway. I don't have a registration pin the right size for this, but the center bolt on this fixture happens to be the same size as the hole in these clamps. If you're wondering why I didn't tap them earlier, that's why, because I was holding it as a smooth bore in order to use it on this fixture first. After clamping it down, I aligned it with the 0 mark on the rotary table. The nose of my clamps, by sheer coincidence, happened to be the same width as the T-slot, so I would just line it up by eye using the T-slot there. And then I proceeded to try and mill a fillet this way. Because of the way this fixture works, the hole has to be the center of the radius, thus I was only able to do a 1/2 inch radius curve on these fillets, and that's too large of a curve, as you can see here. The effect is not very desirable. It's really not what I was going for. Doing a rotary table setup to cut a radius where you do not have a hole at the center of the radius is very tricky indeed, so that's not something I wanted to attempt here. Undaunted, on the second part, I tried a corner rounding end mill. Now, these don't generally work in small machine tools in steel, but I thought I'd give it a try anyway. And it actually worked okay on the second corner. I did light cuts, and I moved in very gradually, a little bit from the side and a little bit from above, so that the most difficult part of the cut, the final radius, was the last part that was cutting on both dimensions, and That worked okay, so I tried it again on the second side, and on this side it didn't work at all. It may be that this cutter is a little dull, and maybe that one side there was the last cut that it had in it. I'm not sure, but I could not get this second side to cut at all. The machine was just rattling itself off the bench no matter how light a cut I tried to take. This cutter was a donation, and so it's of unknown sharpness, as a lot of my cutting tools are. So yeah, this was just not going to happen. So I had to give up on that. So after all these noble attempts at doing this various fancy ways, I just went ahead and filed them. So I filed the remaining 2 parts, and the first 2 parts that had various failed corners on them from other methods, I filed those as well. And well, with all the time I spent trying to avoid filing them, I could have filed them all twice. And then I hit them on the Scotch-Brite wheel to make them look nice. And there's my 4 clamps. Now I can finish up by tapping the hole at the back of each clamp. The way these work is they use a bolt as the heel of the clamp instead of the little stepped block. And that way every part of the clamp is fully captive. It's a bolt holding the back of the clamp and a bolt holding the front of it. Everything is bolted, nothing is loose, nothing can fly out at speed on the faceplate. For finishing treatment, well, if you've watched my channel for any length of time, you know where this is going. Straight into the cold blue. As is tradition, I start by cleaning these up very thoroughly with acetone. Make sure to get into all the nooks and crannies there. Cleanliness is the absolute secret to success with cold bluing. Any speck on the surface that has any bit of grit or oil on it will not cold blue properly. People always ask me how I get such good results with this stuff, and the answer is cleanliness. It's plain and simple. After a moment in the blue stuff, it gets rinsed off in water to stop the reaction, and then dry it thoroughly, and then immediately coat it with oil. The oil is doing most of the corrosion protection. The cold bluing is mostly aesthetic, and the oil will absorb into the surface there, and then you can wipe off the excess, and that will stay rust-free for many years. You can do more than one cold blue treatment. The more times you do it, the bluer it gets. I just do it once and it comes out very black, but you can keep doing it and it will get bluer and bluer each time if you want to go for that real gun bluey kind of look. There's the finished clamps. Sure, they look fine, but do they actually work? Let's give them a little test run here. Here's a sample setup with these clamps. I've got a cylinder casting that's too big for my chuck here, so I'm setting it up on the faceplate, and those clamps are drilled and tapped into the faceplate, and then the heels of them are held up by those bolts. So nothing is loose on this entire setup. Everything is bolted through, and nothing can ever come loose no matter what the faceplate does. Here it is spinning, and you can see those clamps in action. And now you can see why I don't love the idea of using the standard style of strap clamp. Although I should say people do it, and if you look in all the old manual machining books, it was common practice to use standard strap clamps on faceplate setups like this. But I just don't feel great about it, and I prefer to have everything in a faceplate setup through bolted if at all possible. So that's why I made these little clamps. Well, there's my little clamps. These would be a really great beginner milling project. You don't have to go as far as I did with the chamfering and the fillets and so on. You can do as much or as little detail on them as you feel comfortable, and these are going to be extremely functional in my shop. I'm going to get a ton of use out of them, and they were fun to make. So thank you very much for watching, and thank you especially to my patrons who make all of this possible. I really couldn't do it without all of you. Thank you so much for that support, and I will see you next time.